Okay, good morning. We are starting section 5.4, which is the sum and difference identities for sine and tangent. Now, as I mentioned earlier in class, the sine formulas look relatively similar to the cosine formulas we dealt with in section 3. The sine of a plus b equals sine of A times the cosine of B plus the cosine of A times the sine of B. Okay, they're mixed pairs this time, but similar looking equation. And the difference, sine of A minus B, is sine A cosine B minus cosine A sine B. Okay, so for those two equations, the finding the exact value, same process as we did with cosine. So if our example here is sine 75 degrees, a couple of different ways to do that. The one that strikes out to me would be that this is the same as sine 30 degrees plus 45 degrees. So using the equations, the sine of 30 plus 45 is equal to the sine of 30 cosine of 45 plus cosine of 30 and the sine of 45. And then we simply pull the exact values off either the unit circle or a table. Sine of 30 is 1/2. Cosine of 45 is root 2 over 2. Plus the cosine of 30 is root 3 over 2. And the sine of 45 is root 2 over 2. When we put these together, the first part becomes root 2 over 4. And the second piece becomes root 6 over 4, and we can write those together over one fraction. Root 2 plus root 6 all over 4. Cannot take a 2 out of everything because some are under square root sign, some are not. And all of that is equal to the sine of 75 degrees. Okay, so for sine, it's going to be just like we were doing with the cosine, except the equation is just a little different. So make sure you're filling in those equation sheets I gave you so that you have it all put together in one easy spot. And make sure you're paying attention to which formula you need. Okay? For the tangents, the tangent formulas are not as nice. For the tangent of A plus B, it is the tangent of A plus the tangent of B all over 1 minus tangent A times tangent B. And for the difference, very similar. Tangent of A minus B is equal to tangent of A minus tangent of B all over 1 plus tangent A, tangent B. Okay? So the equations are just not as simple. And so to do a tangent problem takes far more effort. If we look at another example, tangent of 75 degrees. We know that the tangent of 75 degrees is equal to the tangent of 30 plus the tangent of 45. Will give us that 75 degrees. So to plug in from the table, first we're going to write out the correct equation, so it's the top one. Tangent A plus tangent B over 1 minus tan A times tan B. And now we fill in. Tangent of 30 off the table is root 3 over 3. Tangent of 45 is 1. And our denominator, 1 minus root 3 over 3 times 1. Okay? So, when we go to simplify this, the top doesn't really simplify. Root 3 over 3 plus 1. The bottom, we have, the 1 goes away at the end, so we end up with 1 minus root 3 over 3. First thing we need to do to simplify this further is we can't have a denominator and a denominator. Got to get rid of that. So to get rid of that, we're going to multiply this whole thing by 3. But what we do on the bottom, we've got to do on the top. And so root 3 over 3 times 3, the 3's will cancel, we're left with root 3. 1 times 3 is 3. 1 times 3 is 3. And root 3 over 3 times 3, the 3's on the bottom and the 3 cancels out, which is what we wanted. We end up with root 3. Okay? And at this point, now we can rationalize the denominator by multiplying by a conjugate. In this case, the conjugate that we need to multiply the bottom by is 3 plus root 3. And what we do on the bottom, we have to do to the top. And when we do that, we get, first term up here is 3 root 3. Outside terms, root 3 times root 3 is simply 3. Inside terms, 3 times 3 is 9. And 3 times root 3 is 3 root 3. The bottom, 3 times 3 is 9. We get a positive 3 root 3, and we get a negative 3 root 3, which is how they cancel. And then negative root 3 times root 3 is a negative 3. So, on top, we have 3 root 3 and another 3 root 3. That'll give us 6 root 3. And the 3 and the 9 give us 12. The bottom, 9 minus 3 is 6, and the root 3's cancel out. We can take a 6 out of everything. 12 divided by 6 is 2. And 6 divided by 6 is 1, leaving us with the root 3. So the tangent of 75 degrees is 2 plus root 3. A lot of work involved. Okay? Couple other problems need to go over with you today. If you're given the problem backwards, okay? Sine 76 degrees, cosine 31 degrees, minus cosine 76 degrees, sine 31 degrees. Well, what is that? Well, if we look back at the equations we started with, difference in the middle means that this is the same thing as the sine of 76 degrees minus 31 degrees. Well, 76 minus 31 is 45 degrees. What's the sine of 45 degrees? Sine of 45 degrees, if we look it up on the table, is root 2 over 2. Okay? So sometimes they'll give us an equation already plugged in. We have to figure out what they were actually looking for. And to do that, we just look at the identity sheets, figure out which identity setup they've got going, and go back to the left side and solve. Okay? And then, of course, find our exact value. They can do that with sine. They can do that with tangent. Tangent of 80 plus the tangent of 55 over 1 minus tan 80 tan 55. Well, plus here on the top means that this was the sum of two tangents. So it's the sum of 80 plus 55. And we know that when we add those together, we get tangent of 135 degrees. And that is our 45 degree angle in the second quadrant. So look that up on the table, and we see that the tangent of 135 is a -1. Okay? That is it for day one of the sum and difference identities for sine and tangent. We'll have more coming up on this topic in just a few minutes.